Good afternoon. Good afternoon. This is Debbie West and Michael Hathaway, the host of Lost Knowledge. We're going to have a very exciting guest today, Michael.
I can't wait to hear him.
Yeah. So his name is Frank Wilczek. He won the Nobel Prize in Physics in 2004, and he's currently a professor of physics at MIT in Boston. His book, he has several books and many articles, but the book I have in front of me is The Lightness of Being, Mass, Ether, and the Unification of Forces. So we're going to be talking to Nobel Prize winner Frank Wilczek today, Michael, and we're going to learn all about physics and his views on this wonderful universe that we exist in.
That's exciting.
That's exciting. So, Frank, welcome to Lost Knowledge.
Glad to be here. Thank you.
Yeah, it's so exciting. So, Frank, this book, The Lightness of Being, one of the reviews says that it will tell you everything you want to know about what it is, meaning, I think, the universe. Right? It says, okay, so let me tell you what it says.
I don't know if it'll tell you what you want to know, but it'll tell you everything you want to know, but it'll tell you what's true and the best that I can do with it. Yeah, the best I can tell you what the world is all about, and the result of many years of hard thinking and study of very strange aspects of the universe that only come out when you look very hard. And
so what is different about the universe than what most of us think? Because we know there's a lot of dark matter out there that we don't understand. We know it's very vast, right? And that we're a very small planet in this very, very big.
We know the universe is very large. It's inconceivably large. You know, the Earth is. If you look at from Mars, Earth looks like a tiny speck in the sky, and Mars is pretty close compared to the next distant star. We now know that the solar system is only a small part of a galaxy, and the galaxy is only one among trillions of galaxies that we can see, possibly an infinite number in the entire universe. Yes, the universe is very big. It's also very old. A human lifetime is 100 years at the outside, and the universe is 13 billion years since the Big Bang. We don't understand what, if anything, came before that, but certainly things were very different then, and things have been evolving slowly now for millions of years. To me, though, those are things that are require a lot of imagination to think about, but people are accustomed to thinking about time and thinking about space and how they might be bigger. What really requires another level of imagination, to me, is the way the world works at a fundamental level in what's called quantum mechanics, where you learn, when you study the behavior of matter in detail, especially when you study the behavior of really small objects precisely, that you require truly fantastic concepts to understand it, that things you thought were reliable facts about reality from everyday life are not. The idea that a definite cause produces a definite effect, that things evolve deterministically, is out the window. The idea that you can separate the act of observation from the development of reality is also out the window. You need tremendous imagination and tremendous discipline to keep yourself oriented and get things right when you're describing reality at that deep level.
So a lot of people have been talking to us about how the Earth is possibly transmuting into a higher dimension, and they describe all these dimensions in the universe. And I wondered what you think about that sort of transdimensional theory, that what we see using our sort of five senses is only part of what exists.
Well, I'm very much in agreement with the idea that what we perceive with our five senses is only a very small part of reality. We can make that very concrete. With our unaided senses, we don't pick up electromagnetic waves, for instance, but with radio and television sets or cell phones, we can. Recently, to get something more exotic, scientists have learned to sense tiny disturbances in space-time, called oscillations in space-time, the so-called gravitational waves that are dramatic signals of things that happen far away in the universe, like black hole collisions. On the other hand, I'm not sure what theories of extra-dimensional reality you're talking about. I don't think it's at all plausible that there are extra dimensions on a par with the three dimensions of space and the one of time that we experience in everyday life, with a very, very wide definition of what everyday life is, including all of science and engineering. There are ideas about unification of forces that invoke the possibility of other dimensions. They're still speculative, but even within those theories, the extra dimensions would be folded up and very tiny. They're not the kind of dimensions you can live in or that you'll see in any macroscopic experience. They would manifest themselves as the existence of new kinds of exotic particles and their behavior. But those particles would probably be are certainly going to be very difficult to produce if they exist at all. They'll be produced at high energy accelerators. So if you're thinking about spirit worlds or moving into extra dimensions and coming back, I don't think physics helps you with that.
Mm-hmm.
How about the God particle that they theoretically have found over in Switzerland there?
The Higgs particle. This is, yeah. Well, I know Peter Higgs, and he's a friend of mine, and the Higgs particle is a very interesting particle, but he's not God, and it's not the God particle in any meaningful sense. It's a very interesting particle that was hypothesized theoretically in a primitive form more than 50 years ago, and in kind of mature form about 45 years ago. And we've been relying on its influence in our equations for a long, long time, and we got very many successful consequences of the idea that the universe is permeated by a kind of liquid made out of a new kind of particle. But until a few years ago, no one had actually produced this particle. It's highly unstable. It's very heavy, difficult to produce. And then it was produced. So it was a great triumph of theoretical and experimental physics, and showed not the existence of God in any sense that would be recognizable to any of the classical religions, but it confirmed the regularity of nature and the fact that human beings can come to understand it and predict unusual, surprising things in advance based on profound understanding of the laws of nature. So it was a great confirmation of the scientific enterprise and our deep understanding of how matter works. So, but I think the name God particle is a little over the top.
What would you call it?
Well, it's not. It's called the Higgs particle after Peter Higgs, a Scottish physicist. That's the standard name in physics, and it's a very handy name. And its role in physics is very interesting. When we formulate the equations, our fundamental equations for the laws, they're especially beautiful if the particles have zero mass, it turns out. When particles have zero mass, they have special properties. The equations that describe them are particularly beautiful and consistent, and a lot of circumstantial evidence indicated that some of the behavior that you would have for zero mass particles, we actually have for particles that don't have zero mass. So it was a kind of quandary. Aesthetic considerations would indicate that we should have zero mass particles, and there were some experimental clues that particles actually existed, that the particles that actually exist behave in some respects as if they have zero mass, but they don't have zero mass. So this Higgs particle was introduced as a kind of cosmic dirt that fills the universe, or a kind of medium, a kind of water fluid that fills the universe. And it's because that fills the universe that it changes the properties of particles that move through it, kind of slows them down, and makes them appear as if they have mass, even though at a fundamental level, if you took this fluid away, they would have zero mass. So that was the idea that led to the Higgs particle. It was a beautiful idea to sort of let us have our cake and eat it too, let us have the beautiful equations, and yet describe reality. And by gosh, it turns out that that was not only a beautiful idea and not only wishful thinking, but actually led to dramatic experimental predictions and then their confirmation.
Thanks.
So, in your book, you talk a lot about matter and also dark matter. And, for those of us that are not, Nobel Prize physicists, these are interesting ideas to try to, understand the complexity of the universe.
Yes.
Do you have an understanding now of what this dark matter is that makes up most of the universe?
No. There's the short answer. But let me elaborate on that. By matter in general now, we mean anything that has physical consequences. So physics now is very, very mature and ambitious. If there's anything that's not described by our equations, we want to improve the equations and get it in there. And after hundreds of years, and especially after dramatic developments in the 20th century, with quantum mechanics and relativity, and then third great revolution, I would say, with so-called gauge symmetries and the Standard Model, we understood at a very deep level, it would be hard to exaggerate how complete and profound this theory is, how ordinary matter works, where ordinary matter includes light, includes atoms, the periodic table, includes everything that's in chemistry or engineering or biology, the kind of matter you encounter in everyday life, with a very, very wide definition of what everyday life is. So as far as practical considerations are concerned, I think it's overwhelmingly likely that we have the equations that we need. We can't necessarily solve them in complicated circumstances very well. We're learning to do that better. But we can use them to design high energy accelerators and experiments that detect Higgs particles. We can use them to design experiments and techniques that will detect gravitational waves. They're very, very sensitive, powerful framework that we've got. Now, when we look out to the sky, however, and consider astronomy, there are some anomalies that are not understood in this framework that's so powerful for engineering and chemistry and physics here on Earth. Astronomers have found that, I should say, for most purposes it works very well, but there are a couple of anomalies that are still out there. One is that in many different circumstances, astronomers find that if you look at the kinds of matters that we understand, so stars, gas clouds, and add up all their mass, and then compare the amount of gravity that mass would exert to the amount of gravity that you deduce from the motion of things orbiting around galaxies, for instance, you find that there's a mismatch, that the amount of mass in forms that we understand is off by about a factor of 5 compared to the amount of mass that the gravity indicates. So the most widely accepted explanation of this is that there's some additional kind of particle that we have not yet identified that was produced abundantly in the Big Bang and is still around, that's providing this additional mass. Now, that might sound like a desperate kind of solution to this anomaly, but it's actually less desperate than it appears. First of all, there's precedent for it. There are particles called neutrinos that were hypothesized theoretically for many years, but part of the theory was that they're very difficult to detect. And but after decades of effort and thinking about it, people devised experiments to detect them. And if neutrinos weighed a little bit more than they do, they could provide this astronomical mass. So some particle broadly like neutrinos could do it. I actually think that a particle that I introduced, or a class of ideas that I introduced to solve another problem, the so-called axion, is a very likely explanation of this dark matter. So this is another kind of particle. It interacts hasn't been discovered yet, let me emphasize, but we're working on it. But theoretically, it's very, very attractive, solves problems that are otherwise insolvable. If you calculate how much it would be produced in the Big Bang and how it survives and how it interacts, it's all consistent with what we know about dark matter. So at present, a very exciting frontier of physics is to devise experiments to detect that particle. So just as for many years the neutrino was a hypothesis but not an observed particle, and the Higgs particle was a hypothesis but not an observed particle, and gravitational waves were a hypothesized phenomena but not yet observed, I think it's similar here. We have a good candidate for what the dark matter is. It hasn't yet been observed, but people are gearing up, developing the technology, building the experiments, the kind of antennas that might be capable of detecting it.
That's exciting.
Yeah, I think it's very exciting. No, it is.
That's exciting. So in all of this dark matter, is it intelligent? Is that dark matter have any intelligence attached to it?
Well, not if it's axions. I think, unfortunately, axions interact very, very weakly, not only with ordinary matter, but also with each other. So they're kind of diffused in a cloud that's, almost particles that don't talk to each other. They just move around. It's hard to see how they could organize themselves into information manipulating entities. But other people have other ideas. Maybe it's not axions. Maybe it's a parallel universe of some kind. So until we understand it better, it's hard to exclude anything. But I don't see any positive indication, and it seems very far fetched that it has any kind of intelligence or. Yeah.
Do you have a concept of other intelligences in the universe, and is there a core intelligence?
Well, intelligence is a very broad concept. It's not one of the things that appears in the axioms of physics. It's an emergent property, as far as we know, and all examples that we know that involve complicated. In impressive intelligence, certainly in all known cases, involves things like brains or computers that are very complicated and constructed like machines with many, many components. Whether there's a primitive kind of consciousness or intelligence in very small bodies, it's partly a matter of definition, but I think you can identify kind of very, very primitive sorts of behavior that you might call the germs of intelligence in even much simpler systems. For instance, I've been very involved in introducing a new kind of particle called anyons. And these are not speculative. These are actual things that are known to occur. They're not fundamental particles, but emergent particles that occur in certain states of matter. And the remarkable thing about anyons is that they have a kind of primitive memory. So if you want to call that intelligence, it's quite a stretch, but they do have a kind of primitive memory. And for that reason, they are thought to be promising building blocks for maybe making new kinds of computers, so-called quantum computers. So if you use a loose enough definition of intelligence, if your standards are low enough, then you can see intelligence even in a very simple objects, and we're certainly developing a rich understanding of the potentialities and possibilities of matter, that where ideas about information and memory and so forth are playing, and those particular concepts are playing a more and more prominent role in fundamental physics.
I got one more question, Deb, if I can.
I should say in the back of all this is, I think, something that you'll resonate with, which is that the world of quantum mechanics is a much bigger world. The equations are kind of much bigger and include much more structure than the world of classical physics. And most of that structure is something we don't ordinarily observe. We're just now developing tools that will enable us to observe and comprehend that universe much better. So there's a vast universe inside us, not just on the very small universe is actually a very rich multiverse, and that's the future, I think, of one important aspect of the future of fundamental science and investigation and technology even is exploring that world.
I live in quite an intuitive world that deals with a lot of people that have the ability to somehow or other get information off objects, off land, off people, dreams, all kinds of different things that come to them in different ways from someplace that seems to be absolutely real.
Mm-hmm.
Do you have a thought on that?
Well, let me put it this way. In physics, we do very, very precise experiments that are very, very delicate, that are unimaginably, far, far more sensitive than human senses or any even the instruments we had 50 years ago. These it would be difficult to exaggerate how sophisticated and delicate and precise and sensitive some of these instruments are to things like magnetic field, changes of temperature, anything. But it's never been necessary in physics, in exploring these things, to ever worry about what anybody was thinking. So I'm very skeptical about the idea that there's a level where conscious thought affects matter in ways that are outside the known laws of physics, just on experimental grounds. And of course, there are many, many ways to fool yourself. There's lots of psychological effects that people think they know things that in fact they don't know, or they have confusions between dreams and reality or whatever. But okay, when someone can demonstrate to me an ability, a reproducible ability, even if it involves very sensitive measurements that are very difficult to affect matter, then I'll take notice. But there's no such thing that I know of.
Thank you, Deb.
Okay, so we're just gonna give you another complicated thing that you can dispute with us.
Okay.
Well, in your book, the book I have, The Lightness of Being, you bring up the subject of God, and you have a quote here about Newton, where Newton had no doubt about God's existence and saw his task in science as revealing God's method of governing the physical world. So that sort of brings in this spiritual component of, a divine creator, the universe isn't random, we're not here by accident kind of philosophy. I'm pretty sure where you align with this, but can you talk about it for a minute? Because certainly a lot of physicists over time have gotten involved in this conversation about how do you marry, science and the spirituality aspect of what we've determined who we are, how we exist here.
Many of my greatest heroes in physics, in fact, most of them historically, were devout people, and Newton was almost was devoted as much time to theology and investigating what we would call biblical scholarship today as he devoted to physics. And Maxwell, perhaps my favorite physicist of all, was also a devout Christian, and he and Faraday and Galileo, and the list goes on, Kepler, all these guys were very convinced Christians in most cases, in all cases actually, and they thought of, as I said in the book, I think this is really quite profound. They thought of what they were doing as revealing how God makes the universe work, how God operates the physical, how God has chosen to express himself or itself or herself, but for them it was himself in physical reality. And okay, and now times have changed. Now people, I certainly think that there's been a lot of sophisticated analysis of the so-called sacred texts. We know a lot more about their origin and their pluses and minuses and so forth. So I think, I started out, I was trained as a Catholic and was very moved by it as a child and young adult, but I don't anymore think that the scriptures have any authority as reliable guides to physical reality. On the other hand, I'd like to think, and I do think, that my approach to my work in my life is still a continuation, a recognizable continuation of the approach of those heroes, which is, but now with a slightly different slant. I mean, they thought that what they were doing was figuring out how God worked in detail. I think of what I'm doing as figuring out what God is. Different people have different ideas about what they mean by God. It's not a word that has a definite denotation, as they say. It's, people have vague ideas or different ideas. But to me, the investigating kind of these ultimate questions and understanding with honesty and rigor and as deeply as you can, and really working hard, really getting it, that to me is finding out what God is.
So at the moment, what is your hypothesis of what God is?
Well, I can show you the equations, and so to me, the deepest the way the world works, which to me, at the most profound level, and I don't see any evidence that there's another level. The way the world works is described by incredibly beautiful equations that were not the things you would guess, that have much more structure and much greater depth than anyone could have guessed. That's where I want to find solace, relief, interest, whatever you want to call it, spiritual values. So they're very, very beautiful structures. You can be creative with them. You can sort of make new things and have some of the experience of creation that I think also is what we think of, well, it's commonly associated with God and spirituality. And one can also understand the history of the origin of things. So that's, as I said, it's not God in the sense of any particular scriptural tradition, but it's kind of God in the making and emergent God. And I like to say, people sometimes ask me straight out, does God exist? And I say, not yet, but we're getting there.
We're fine. We're looking. Let me talk to you about some of the things that are coming out in modern physics as we become a spacefaring nation. I'm in Houston, Texas, and as you know, in Houston, they're planning to colonize Mars. They're colonizing various asteroids for mining of different minerals. We have 4 spaceports that will be going into lower Earth orbit and also into deep space. This is an exciting time for Earth, as we're not just going to, pontificate about the universe. We're actually going to project ourselves well into the universe, places that we've never seen before. What do you think about wormholes as a means of travel? And what do you think about time travel as a possibility? Because it's pretty hard to get across the universe using something.
It's very hard. Okay, so let me make 2 remarks. First, I'll answer your question directly. I am not optimistic at all about either wormholes or time travel. And that's based on my knowledge of the laws of physics and about the nature of space and time that emerges from profound study of the laws of physics. And those laws, for instance, notably, very relevant to this question, predicted the existence of gravitational waves, which are exactly distortions in space and time. But what the equation showed and experiments verified is that to produce extremely tiny distortions in space and time, you need extremely violent effects. So the gravitational waves that were detected, what they were operationally was tiny distortions in the distance or oscillations in the distance between arrays of mirrors. The mirrors were about 4 kilometers apart, and the displacements, the oscillations that were involved, had a magnitude of about 1/1000th the radius of an atomic nucleus. So it takes collisions of black holes that weigh 30 times the mass of the sun colliding to make those tiny, tiny distortions in space and time. So if you want to produce distortions in space and time that people could travel through, well, all I can say is good luck. There's no way. No way with any known current idea that even gets remotely close to to that kind of vision. Now, of course, the future. You never say never, and never is a long time, and it's possible that some completely new revolutionary idea will upend this conclusion, but I don't see any sign of it, and not even so. Don't hold your breath is all I can say. But on a much more optimistic note, I think that's the wrong question, and I also think, frankly, that the whole program of sending human bodies into space is kind of misguided. Human bodies are not evolved and are not well suited to live outside this narrow biosphere where we find ourselves. It's very, very difficult to maintain existence out in space. As you know, there have been many disasters. It's been a very slow process. After a glorious beginning, putting people on the moon kind of petered out. It was very expensive. But what we've learned, but we've had glorious things in space, though, with instruments and robots, and we can project. We don't have to project our human bodies out there in order to experience what's out there. And I think that some kind of combination of robots, cyborgs, people that are man-machine hybrids that are better adapted to space. Probes that are, or you can send seeds and grow appropriate kind of biological, quasi-biological beings out there, that human intelligence and human civilization will spread into space, but not necessarily human bodies. I think the idea that, you go into space like you travel from New York to Los Angeles. I think I think that's just wrong-headed and not going to happen.
Let me follow up on that question?
Yes.
That's the quasi-human being. That's a very interesting phrase. Do you think that there's a possibility that something like that exists already in space and time?
Yes. Oh, yes. Well, look, I mean, we don't think of it that way, or I mean, it's not usually phrased that way. But You look, I'm talking to you. You're far away, right? And I'm talking to you. And if I turned on the video, I would be able to see you. So in a real sense, my body, my senses extend over thousands of miles. You know, people 100 years ago would have thought of this as magic and totally impossible. But all you have to do is extrapolate that from thousands of miles to millions of miles and light years, and you begin to understand the possibilities that human consciousness and human sensation and human ability to manipulate things could extend over vast distances as a practical thing, even if the actual human bodies have not traveled from Earth.
So you call it the astral body?
All of us now are extended beings. We routinely interact with the whole world through the internet, through telephones, and so forth. So in a real, and it's going to become a much more intimate experience as sensors and effectors become more sophisticated, which they rapidly are. So people will soon, I think, within years or decades at most, have a real sense that their consciousness extends to remote places. I've already had the opportunity to experience things like that, by having a robot that respond far away, that in Sweden actually, that controlled from Cambridge, that was responding to what I was doing at my terminal. And I could see it controlled what I saw in Sweden, and I could move around and touch things. And if you experience that for a while, you forget that your body is back here in Cambridge, and you're living vicariously. I think that's going to become a common experience and a richer experience, and people will cease to think of themselves as localized in a body. And, then there's a whole other level of artificial intelligence and bioengineering. And I think the human beings are going to evolve in ways that at present can barely be anticipated.
That's a different dimension, right, Deb? That's what she was asking about, other dimensions.
Well, okay. I mean, if you call that it's not a dimension in the sense
or density, they call it
north, south, north, up and down, or north, or either or east or west. It's an expansion, a huge expansion of human potentialities. I think that I agree with that. So, with the very loosest definition of more dimensions, yes, that's an expansion of human consciousness and capabilities that's coming. I'd like to think. Well,
I'm asking too many questions. I'm all excited about this. Do you think that there are intelligences out in the universe that might communicate with us the same way?
Possibly. The universe is very, very big. So even if all these developments come about and humanity starts to expand its reach, to Mars, you were talking about. That's okay. That's a step, but to the solar system and then to the nearby stars, it's there's no clear roadmap that is on, except on an extremely long time scale, to millions of years maybe, unless we to expand throughout a sizable part of the galaxy. So if other intelligence exists, even in our galaxy, let alone in other galaxies, it may be quite a while before we come into contact with them. But it's certainly logically possible, and it would be very interesting. But it's it's at the fringes of speculation at this point. We don't have any definite knowledge of such things, and we'll just have to keep trying and be patient and watch, and maybe it'll happen someday.
Maybe it will. Well, yeah, we do. We talk to a lot of people, and they may be a little bit what you call on the fringe of physics because they don't have the science to back up their claims, but they will tell you that they are able to connect telepathically to beings or minds, I guess you could call it, not necessarily human beings, but some sort of intelligent mind where they can download data on, different things that they're working on. If it's some form,
Well,
I mean, for instance, Nikola Tesla, he claimed, that he was driven by information that was given to him from an off-world intelligence, and that's where his designs came from. And this is something that gets repeated a lot in people's as they get older. They write their biography. They'll talk about their connection to something beyond their own limited mind.
Well,
beyond.
I've had the experience that ideas come to me, and I don't know where they come to me from, but I'm very much aware that I don't understand my own brain very well, and there are lots of things I can do that I don't know how I do them. Even very simple things like talking to you. If I tried to program a computer to talk fluently in English, I wouldn't be able to do it. Obviously, I don't know how I do it, and lots of things I don't know how I do, and I don't know how ideas come to me. And yeah, I can imagine convincing yourself that they come from some external source, but I don't know of any evidence of that. And I would challenge any person. Okay, if such a person, any such person, here's a challenge to them. You can find big numbers on the internet that no one knows that have factors, prime factors. And there's no fast method known to find those factors. Okay, this is the basis of encryption on the internet. This kind of problem. So, if anyone could consult an alien intelligence to solve that problem for them, they could become very rich. They could hack secure messages. They would have access to anybody's bank account and so forth. So, okay.
Now that would be a sort of a malevolent way to use your power.
Well,
one of the things they do say is
do it as a test. Okay, you don't have to you don't have to use the information. Just give any clue, any sign that you could actually do it.
Right.
Then I'd be totally convinced. But
there you go.
Maybe you could set an intention to dream a formula for that.
My response is kind of the classic response, which is, okay, if you're so smart, why aren't you rich? All right, so okay. I mean, if you could really do that, there are all kinds of things you could do, and okay, show me, do it.
Maybe it'll come to you spontaneously in a dream, like a formula.
Well, that happens. There's nothing mysterious about that, though. I mean, dreams, are, as I said, nobody understands their own brain, even remotely. I mean, that's a big lesson of computer science, is that many things that people know how to do, they don't know how they do them. Most things are done unconsciously. We don't know. It's even been very difficult to teach a computer teach a machine how to walk. That's really an unsolved problem. Or how to see things and identify objects in a scene. Very, very, people do it easily and routinely, but they don't know how they do it. So there are lots of things we do that we don't know how we do them, and it doesn't surprise me that at all, and I've experienced it myself, that you have ideas and you don't know where they came from. Okay, so that doesn't impress me at all. I mean, it's an interesting phenomenon, but there's nothing terribly exotic about it, I don't think.
Sounds like quantum physics.
So, Frank, do you think there's anything to time travel, though? Can people travel through time?
Not based on the physics that I know. No. That's not, since space and time are related, that's not entirely a distinct question from can you distort space-time? And we know the answer is yes, you can distort space-time, but it's really, really hard. You have to bang together black holes to make a tiny distortion in space-time. So the idea that you can loop back in a big way in time seems very, very far-fetched.
But a mental hybrid could do that.
Well, a mental hybrid could do something that's kind of like that in this sense. And we can do this too, but in a limited sense. If you have a system that's very well characterized, then you can go ahead in time and evolve in a certain way, and then you could do it again, or you could run it backwards. If you have a movie or a computer program, you can certainly, if you know what the state is, you start and run it. You could do that again, or you could run it backwards. So in that sense, you can repeat experiences. In that very loose sense, you can you can put yourself back to where you were before. And if you were an artificial intelligence based in a computer, so you had complete detailed knowledge of your state and how you evolve in time, then you could time travel. Then you could go back and loop back. If you had an experience that you particularly liked, you could reproduce it exactly. So in that sense, there's time travel, but I don't think there's time travel in the sense of distorting, of manipulating physical time to revisit the past. There are also, as you undoubtedly know, there are all kinds of paradoxes involved in that too. You shoot your own grandfather and so forth. So, but those are logical paradoxes, and maybe there are ways around them. I think probably there are, but there's no indication of physics as we know it, which, again, it would be difficult to exaggerate how powerful and complete our knowledge of ordinary matter is. There's nothing in that knowledge that, to me, suggests any remotely practical way to do time travel.
So do you think that this is way off subject, and I apologize, but I have to ask you, do you think that when people die that they have a life after that?
Well, their bodies don't.
Right, but their consciousness could.
But, if they've done good work that people record, if they have friends and their memories live on, and so there's a kind of life that's not life of your biological body.
Well, there you go. The wonderful description of our universe, the physics that we know, the physics that we can understand about the vastness of this magnificent universe. And the more we learn, the more we can grow and understand things, and perhaps create a more sovereign, peaceful planet in the process.
That was wonderful.
This is fascinating. I can't wait for your next formula.
Okay, thanks a lot.